Hello, everyone. Hola. Boa tarde. So again, my name is Raquel Velez. I'm Rockbot on Twitter, GitHub, etc. I really love it when people come talk to me and ask me questions on Twitter. Sometimes turn it into blog posts. So please do not hesitate to ask me any questions on Twitter, in real life, whatever. I'm on IRC too, whatever. Okay, so let's get started. I work at Sauce Labs, which is pretty much the most amazing company in the world. I love working there, even though I get really frustrated trying to make mobile devices do what I want them to. Sometimes you can't just stare at them and tell them, work. They don't respond very well. But I love what I do. I love my team. And if you want to talk about mobile testing, automated testing, again, come reach out. So what's a NodeBot? How many people have heard of NodeBots or played with NodeBots? If I can get a little bit of a light up in the house, a little bit, so I can see. All right, so we've got about 50-50. Keep the lights up a little bit. So I do this weird thing. It's called the dial. Instead of just hands up sort of thing, I actually, if you think about a dial, right? So this is a 0. This is super awesome, and you can vary between 0 and 1 or 100. And so, how many of you think that robots are cool? Yeah. All right. So how cool are robots? I guess is the better question. Great. And how many and how hard are robots? Are robots super hard or really easy? Where do you think that they fall? Really hard. Okay. Yeah, I guess they're really hard. But with Node, they're not as hard. With Node, which is really just JavaScript, it's not that hard. How many of you are into JavaScript? How well do you know JavaScript, would you say? Ish. Yeah, I'm kind of a here-ish myself. But it's amazing. And today I want to talk a little bit about NodeBots and what that means. But first I want to show you what NodeBots look like. So it starts off with some really basic hardware and electronics. Arduinos are really popular. How many of you think that if you play with robots, you're going to get electrocuted? Yes, I'm going to get electrocuted. No, I'm not going to get electrocuted. Yeah, okay. In this particular scenario, you're only dealing with 5 volts. It's 5 volts. It's not that much. It's less than a 9-volt battery, which, it's that square one, right? It's just a couple of AA batteries. So you can't hurt yourself. Really, you can't. At this level, don't worry about it. Worst thing you're going to do is burn up a couple of components. But here's some more fun NodeBots. Once you start with the basic Arduino and electronics basics, you can start building all sorts of crazy things. You can start building competitive robots. You can even start hacking into hardware that you didn't even create, that you bought off the shelf. This is a little crazy fly. And you'll be hearing more about these a little bit later, but if you've seen these around, you know that they were powered by Node in some cases if you want them to be. And then, of course, the whole point is just to have fun, right? And these are all robots that have happened just within the last year by people who probably just started the day of. I think a lot of these were put together in a matter of hours and do some really cool stuff. So, yeah, but JavaScript, right? We can go ahead and put the lights down now. I'm not done asking questions. So I've been a roboticist for over a decade. I've worked at places like Caltech, MIT, NASA. I've worked at universities around the world. I've done my fair share of Python and C++. So I was a little skeptical too, right? JavaScript, that's a web thing. What's it going to be used on hardware for? But I've changed my mind. JavaScript is amazing for robotics. And while, yeah, okay, fine. The benefit of having C++ and Python are that they're multi-streams and it's fantastic, and JavaScript is like single stream, single process, whatever. But here's the thing: you already know JavaScript, right? Everybody's hands went up when I asked you how much JavaScript did you know, right? I mean, nobody here said, "Oh, I know nothing about JavaScript." You know JavaScript already, so you're ready. Let's just get started. You don't have to have a PhD. In academic robotics, it's like this whole thing about you have to have a PhD, and you have to get funding, and you have to make sure that you have to sign off on a million things and pay lots and lots of money. But in this case, you don't have to worry about that, because it's open source. And we're talking about little Arduinos, which cost like $20, probably similar in euros. You don't have to worry about compiling. It's JavaScript, so you just refresh and have it start over. And I don't know about you, but over the course of the last 2 days, over the course of the last year and a half or almost 2 years that I've been doing JavaScript, I've made so many friends, and y'all are kind of awesome, so we all get to hang out and build robots together. I don't think that's so bad. So the NodeBot revolution, it's happening. It's been going on, and let me go and do a little bit of history. So it all starts out with this guy, Chris Williams. You may know him as Voodoo Tiki God on Twitter. You may better know him as the creator of the JSConf. Great guy. One day he decided that he really wanted to start using JavaScript to talk to devices over serial. So he created Node Serial Port. And then there was a guy named Julien Gauthier who said, wow, okay, so I've got serial. What if I build on top of that and hook it up to an Arduino? So he created Fermata, also based in Node. And then Rick Waldron came along, and he's really big into jQuery. He's on the JavaScript committee. And he said, okay, wait, so we've already got Node Serial Port. We've already got Fermata. So what if I create a whole system that's all JavaScript, and it looks like jQuery, and use it to power robots? And so he created Johnny 5. And all of that come together, and now we've got NodeBots. And it has seriously started something crazy. Crazy. Just in the last year, I'm just talking within the year 2013, we've had NodeBots Day, an international event around the world. We had countries all over the world. It wasn't just the US, it was US and England and Colombia and Australia. I mean, so many countries were participating. And that led into NodeBot meetups, right? And so now in San Francisco and New York and hopefully London soon, there are these events where people gather together and they just start building robots for fun. And then there's going to be a book. I mean, NodeBots, all the things. So it's a revolution. It's just hit us just smack in the face and says, let's do this. Hardware. So what's next? There's so much that I could talk about and so many things that I could do, but I really want to point out that one of the benefits of using JavaScript is something that I don't think most people think about. In the world of robotics, we use C++ and Python and other related languages because that's what everybody's been using forever. But the beauty of diversity of thought is that it brings new ideas, right? So what happens if we bring in JavaScript and we have all these brilliant people playing with JavaScript and they have no idea, what is supposed to be happening, and they create solutions to problems that everybody else has been having for years? What if we could do that? What if we could totally redefine robotics using this silly little web language? How cool would that be? And how cool is it that you have that power in your hands right now? So, okay, so let's take it a step further. What do we do next? Now we make them smarter. That's what my whole background in robotics, believe it or not, despite the fact that I have a degree in mechanical engineering, I don't like electronics. I have just been programming my whole career. And so I've been doing artificial intelligence and talking about path planning and kinematics and all sorts of crazy, high-level type stuff. So I created this module called Vector. And Vector is really simple. It's just, it's a robotics-focused linear algebra module. So there are a lot of matrix math and vector math type modules out there already, but none of them are focused on robotics. I want to make it as easy as possible for all of you to get started and playing around with this stuff. So I created Vector. It's open source, pull requests welcome. This is how we start building our robot army, folks. So let's do this together. All right. So this is my latest project. It's not done yet, so keep that in mind. But I wanted to show you what I'm working on, and I wanted to show you the process that I went through to kind of put this robot together, just to get started. This is version 0.1.-2. But the goal was, I want to identify potential obstacles surrounding me. I want to know how far away an obstacle is and what direction it's in, right? So let's say you're walking around, you want to know how far is this podium from me? What direction is it in? How far is that away from me? What direction is it in? Should I turn? Eventually, you want to start out at the very basic level. Do one thing for now, and then move on to the next thing. So the way to achieve this goal is with sensors. You want to allow your machine to get some understanding of what's surrounding it. You have to remember, without sensors, the robot knows nothing, has no clue about anything. Imagine yourself without eyes, without ears, without a nose, without hands. You would have no idea what's around you. That's how you learn and understand what's in your environment. So we're trying to give those same sorts of magical powers, if you will, to the robot. So for this particular exercise, I have a few options. So I could be working with a stereo camera pair. What is that? Think of your eyes, right? You have two eyes. And your eyes are actually the reason that they're a little bit of a distance apart is so that you can actually do some really tricky, not that tricky, but fun math in your brain that says, okay, so if you close one eye, you see one picture of the world, and then if you close the other eye, you get a slightly put to the side picture of the world, right? And then you use, your brain does some calculations, and it figures out, that's how you do depth perception, figures out just how far away everything is, because it basically takes landmarks, and it overlays them, and it says, okay, so this is this far away, this way, and I know the distance between my eyes, so therefore it must be this far away, right? So it's a little bit of trigonometry. What this basically means is that you end up getting an amazing quality picture about where things are and how far they are from you. And it's not that expensive, right? Cameras, you can buy some really cheap webcams, you can just put them together, but making it all work, you have to have some OpenCV or something similar, some sort of computer vision processing library, and then you have to make sure it all works on the back end and the front end, and it gets really exhausting. It's really a lot of work. So it's a high level of difficulty. Then you have something that's called a LiDAR or a LiDAR. You might have heard them called different things. And the quality varies. It could be pretty good or really good depending on how many dimensions you have it in, right? So if you just have a LiDAR that scans this way, you get one dimension of information, because the way that a LiDAR works is it basically sends out a laser beam and then waits for it to come back. And it calculates that the time, so in the amount of time that it takes for the laser to get back, that's how it knows how far something is away, right? So then it does that basically doom, 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 like that. And so with that information, it gets points in a stream. And you can use that information to kind of get some information. If you have a two-dimensional sort of LiDAR, whether it's with a point cloud stream where you just have a LiDAR that goes like this and like this at the same time, then you can get more of a two-dimensional view of the world. So that's pretty interesting. But those are really, really expensive. I mean, I'm talking tens of thousands of euros, maybe hundreds of thousands of euros. It's pricey. So it's pretty easy to implement, but I don't have that kind of money. And then we have a sonar, which I'll go into a little bit more detail, but let's just suffice it to say the quality is pretty bad. It's not very good, but it's really cheap and it's really easy to implement. And when it comes to hardware, sometimes you just need to do a proof of concept first. So start with the cheapest thing. That way, if you break it, no big deal, get another one. But if it works well, then you can say, OK, this works. Now I'm going to pony up the money for the next big thing, or time, depending on what's more important to you. So I went ahead and got a sonar. About $25 on SparkFun. Not too bad. It's cheap, it's easy, it's great for testing our proof of concept. And it lets me name my robot BatBot, because bats navigate through sound. So, and look at the wings. It's cute, right? Okay. So let's understand a little bit more about what's going on with our sonar. So the way that a sonar works is, just like with the LiDAR, it sends out some high-frequency sound, right? And so the sound goes, and then it calculates the amount of time it takes for it to come back. And so great. So just like a LiDAR, it uses time and maybe even power to, by power I mean like how much of the wave comes back, to determine how far away something is. But it doesn't have any sort of directionality. It's just, and then, so that's great, but then you also need to understand how it's doing that. And so it's important to read your data sheet of whatever thing you buy so that you fully understand what is going on when it's doing things that you want it to do, because there's the possibility that you think it does one thing and then it does something else. That's a lesson to learn from. But basically the point here is that instead of it being a nice single point beam, it's actually a cone, and it creates this bloom, right? So instead of like this, right, it actually does this. And so you have to understand that when it puts out its beam, anything that falls within that cone, it'll return as a value. So keep that in mind. You'll also notice these little squares. Those squares are about, it basically says that those are about a foot wide, which in metric is about 1/3 of a meter. So 3 of those is approximately a meter. So this cone can get pretty big. And so, again, keeping all that information in mind. But like I said, it's only in a single direction. It only goes like this. So if we want to get a bit of perspective, we need to basically sweep it back and forth, right? And so I originally wanted it to be 180 field of view, but given limitations of the servo that I have, it's really more like 165. So it looks kind of like this. Just a basic understanding of, this is the field of view. I didn't want to do a full 360 because that would add more complications and blah. So for now, 165 degree of view. We just want to prove the concept, remember. So we have BatBot. Yay, BatBot. It's adorable with his little wings. And now I'd like to show you a demo. So just to kind of, hopefully the camera can see this, but basically this is a sonar right here, and we've got a servo. So the servo is going to move the sonar around. And on top of the servo, I've put a laser so that we know exactly what's going on and when, and which general direction it's pointing. But remember that the laser is a single point, and the sonar is a big old cone, right? Okay. So let's do this. And all right. So I've got this little Node app. And what it's going to do is, okay, so hopefully you can see a little laser beam as it's going around, and you can see that this little part here is actually this LXJS bit, and everything else is too far away for it to register on our little map. but as it comes sweeping back, but watch carefully, because you'll see the cone, the bloom. It's going to start hitting stuff, and then it's not really going to register anything. And then it suddenly does. And as it comes back, eventually, it'll go past this styrofoam bit, or it might just decide not to do anything. Meh. All right, so that's generally the idea. And so here's actually a slightly better video. You can see that we have this box, and this is how it kind of results. And then you have this little bit of space, even though it looks like a way bigger amount of space here. And we just have this another box right here. So it's not the best, but it's a good first pass, right? I can see, for the most part, that there are objects in that general direction. So let's just pretend that BatBot is really nervous and wants to give it a nice, good bit of cushion so it doesn't eventually hit all that stuff. So that's all I've got for right now. But hopefully that at least gives you some idea, some notion that it's not that hard. It's pretty easy, actually. You just have to start applying some basics, and then when you're ready, you can start moving on to some more advanced stuff. And I like to talk about those things online and ask me questions, anything. But what's left? Obviously, this is version 0.1. -2. There's a lot more to do here. I would love it if BatBot moved. I would love it if I could upgrade the sensor for more granularity. I would love some wireless communication. Right now, I'm kind of stuck with this little thing right here. But I'd really love to just have it run around, and then I can kind of, use a little joystick to get it going. Love to do some object avoidance, and that's basically actual algorithms that artificial intelligence algorithms that say, oh, there's something in the way, let me move back, let me kind of turn around, oh, nope. So it's some basic path planning. And I would love to add some computer vision at some point as well. So if you would like to help me, please do. I will put everything online so that you can build your own BatBot if you want to. And so hopefully that's enough to get you excited. Hopefully that's enough to get you started. If not, let me know. But it's your turn now. Continue the NodeBots revolution. I can't wait to see what you build. Please let me know. Reach out. Talk to me. I'm super excited. If this is 2013, I can't wait to see what's 2014. Thank you very much.